Okay, so what we're doing in this section, if you were here last year, it's a review for you, and we've talked about it a little bit this year. Isn't this equation solved for y and simplified, right? If you've got y by itself, it's in the form y equal mx plus b. As a matter of fact, I'm going to come up here above it and I'm going to label it that way because this is a technique you can do with equations. If you're not sure what part's what, it kind of puts it right in front of your eyes. Now, the m, it's the number in front of the x. It's not the x, okay? You don't want to put the x down. That's the slope. It's just the number in front of the x, and you do take the sign of the number with it. So if I'm looking at number 1, what is my slope? 2. I don't have to write it as 2 over 1. If I want to count it off on a graph as rise over run, because I know the slope is rise over run, I could write 2 over 1 if I want to count it off, but I normally would just say the slope is 2. I don't want, in math, when we're telling our answers, it's like you're trying to communicate as clearly as you can the information. So you don't want to make it more confusing by saying 2 over 1. You just want to say 2, okay? So that's our rise over run we would count off. If I were going to graph this, for instance, they don't ask me to do it here, but we'll just practice as we go. If I were going to graph this, I know the slope is 2, but I can't even start graphing it because don't I have to have a starting point to count slope off, right? So what am I going to do if I've got a slope of 2, but I don't know where to start counting? Well, that's what the b is, right? The b is, we call it the y-intercept. It's where the graph is going to hit the y-axis. Where the graph hits the y-axis. I can also call it my starting point. So it's kind of, you know, we usually say that's the y-intercept, but that's where I'm going to start graphing from. So I'm going to call it also my starting point just because it's helpful to think of it that way, especially if you're kind of fuzzy on all this stuff. So what is my y-intercept, my starting point here? 1, okay? Now, when I pull it off the equation, I say 1, and I could go graph it that way. Here's the y-axis. It's the y-intercept. So I go to the y-axis for the y-intercept, and I color in 1 on the number line, basically. It's right here. But if I want to call it, if I want to refer to it as a point, what would I write? X is 0, and y is 1. So let's get used to writing it that way. X is 0, y is 1. As a matter of fact, weren't we finding x and y intercepts before we left for spring break? And you remember when I wanted to find a y-intercept, I always set the opposite variable equal to 0. What did I set x equal to then? 0, right? So you can kind of see that here. If you have trouble naming the point on a y-intercept, you would have set x equal to 0. And if you wanted to do it algebraically and figure it out, you could set x equal to 0, plug it in, and solve for your y. Or I can just graph it and say that's the point 0, 1. There's that connection there, okay, with something we've done before.
Do we have a test on Thursday?
No. Oh, by the way, no test. That part, when I pulled it up on Course Sites, it was scrolled down, and I didn't see it till I printed it out and looked at my printout this morning. No test Thursday. That was like before I rescheduled things. I kind of slowed things down because I knew we were struggling. Some people were struggling.
I want there to be a test on Thursday.
No, you don't, because you don't know the material yet. There's a lot of stuff you haven't learned yet. So no test on graphing it. You don't have to on this problem, but now that I got my starting point, I can graph it because I know my slope is 2. Slope is also rise over run. So if I want to turn 2 in a fraction so I can count it off, I can put it over 1, right? And that means I rise 2 and I run 1. There's another dot here. I went up 2 and over 1. Let me tell you something I see people do, and I want you just to make sure you know that this is not the way you think. When I rise 2, you know, I might put a dot there just because my pencil landed there accidentally, but am I through counting my slope? No, because I didn't run over 1 yet, right? So the point is right here where I'm drawing the big purple dot. There is not a point over there, another point on the y-axis. There's only one point on the y-axis, and it's your y-intercept, 1. So there's not another point where that little tiny purple or little tiny red thing is there above the big red dot on the y-axis. That's not a point. That's just part of the counting, but you're not done yet. So don't put a point there and think you're supposed to go through that point. I see that on a lot of people's papers, so just want to clarify that. So if I want to graph my line, all I got to do now is do that and I'm done. Okay. Let me start with 5 up in the oral exercises because we just had a question about that, and it was a great question. What do you do when they only give you this, y equal 5x? Well, I can write the formula below it, and it'll help me figure it out. Y equal mx plus b. It's easy to see what the slope is. What's the slope? 5. It's just 5, not 5x. Do not write the x, okay? Now, McCabe asked, is the y-intercept 0? He is correct, right? Isn't 5x equal to 5x plus 0? They're equal amounts, aren't they? Why do you think they didn't write the plus 0 down? It makes it harder, but it's that lazy math guy thing, right? Lazy math guy is not going to write down anything he doesn't have to. And since plus 0 would hurt his itty-bitty hand to write it down, he is not going to write it because 5x is equal to 5x plus 0. And he thinks, oh, but 5x is simpler than 5x plus 0. So he doesn't write it down. So what we have to do is think it. We have to go, okay, 5x is the same thing as 5x plus 0. My y-intercept on that one would be 0. So it would be the point, x is 0, y is 0. There's a lot of other weird stuff. First of all, let's look at something that's not so much that it's weird. It's just you got to think about what you know about math here. On some of the problems, like on number 7, look at this. Y equals 8 minus 2x. Did they put it in the form that you kind of want to look at it in? Is this in y equal mx plus b form? What do we got? What do we have to do to it to get it in that form, though? Yeah, you're just rearranging the terms. The negative goes with the 2x, and that's a positive 8. So I can't just write 8, can I? They're added together, so I need to put a plus 8. It's just that, when you rewrite it, you got to remember that's a positive 8, so put a plus 8. So what would your slope be on number 7? -2, the number in front of the x. It's not that you couldn't have found it, because you can find the x and look in front of it, but some people, when they don't rewrite it, they get more confused on the y-intercept. They go, well, where's the y-intercept? It's not on the end. Well, it's 8. It's in there, right? So, yeah, I just switched the terms. I just rewrote it because I wanted that y equal mx plus b. It has the x term first. When we write the x term first and then we write the number, we're putting it in, not only does that put it in the form where it's easy for us to see what the pieces mean, but this is also kind of a standard practice in math to put your variable terms first and then your plain constants, your plain old numbers are called constants. You always put those on the end. It's just kind of a polite way to communicate in math. So if we put it in that polite form, it actually helps us because we also now have all the parts in the same order we were used to finding them in. So my y-intercept is 8, and if I write it in a point form, the y is 8. Remember, the y is the second part of a point. What would the x be? How do you find a y-intercept? You set x equal to 0, okay?
So do we have to write
Okay, I want this in y equal mx plus b form, right? Is it in that form? It is, but lazy math guy didn't write a whole bunch of stuff down, did he? Because what's in front of the x that he didn't write down? A 1. He was just too lazy to put that 1 in. He figures we understand that it's there. And then he didn't write the y-intercept down either, did he? What's the y-intercept here? 0. Because x is equal to x plus 0, and all that's equal to 1x plus 0. So I can fill all that stuff in, and it helps me to do it, right? Because there's so much missing, it makes it hard to think about. What's my slope here? 1. The number in front of the x is 1, right? What's my y-intercept here? It's 0, and if I were just graphing it, I would just go say, oh, y is 0. There's the y-axis. It's 0 right there. Of course, I'd have my marks on my page. But if I want to write it as a point, isn't that x is 0, y is 0? And when I find a y-intercept, I always set x equal to 0 if I was doing it with algebra like we were doing before. So that's another way to remember it. You know, when you find an intercept, you set the opposite variable equal to 0. So there's another way to get it if you prefer that way of thinking. And then I could go rise 1, run 1. There's another dot. Rise 1, run 1. There's another dot. Rise 1, run 1. This is actually a special equation, and your book doesn't approach teaching this way. But when you get the equation y equal x, that's called the parent function of a line. Go ahead and write this down, because we're going to learn some other forms of lines, and actually all the equations you learn in Algebra 2, you learn about something called a parent function. And the parent function is the simplest function, the simplest type of a function you can write.
And it's y equals x.
Yeah, like for a line, y equal x would be the simplest thing you could do. It always, a parent function always goes through the origin here, and see how this one's at the origin. Parent functions always go through the origin, and they're always as simple as they can be. So if that goes to the origin, the simplest thing would just be have a slope of 1. It's usually y equal x to whatever power you're looking at. So for a quadratic equation, those squares we were doing, it would be y equal x squared. Come on. Okay, number 11. Is that in y equal mx plus b form? It doesn't look like it. I can make it work. This is not what most people do with this problem. I could make it work. If that's just the number part, what's missing is the x term, right? What do you think got multiplied by the x term to make it go away? 0. The slope would be 0. Now, how I told y'all to learn it is how most of the time you think about this, y equal anything, no matter what number it is a horizontal line, isn't it? And what's the slope of a horizontal line? It's 0, okay? Because if you remember, we were talking about the skier. If he was on a horizontal line, how much fun would that skier be having skiing on a flat surface? He would have 0 fun. He'd be working real hard. He'd be getting lots of exercise because he's having to scoot himself along. But he's not getting to slide, and that's what's fun about skiing, is getting to slide and go. So he's having 0 fun. The slope is 0. And you could actually write that with a 0 in front of the x and see where you might get that. If you could actually put that in y equal mx plus b form. What about the horizontal lines? X equals something. That had an undefined slope, didn't it?
Wait, which section are you on?